The last skill that we're going to review with your rationals is solving. So a reminder first that when you're solving, you're looking for a value of the variable, like x or y in this case, that makes the equation true. So you want something in the end to say x equals or y equals, and you're looking for a value. The second thing I want to remind you of is you have solved rational functions before. It just gets a little trickier when you have the variable in the denominator. So I want to remind you of maybe simpler problems that you've solved. Let's say I solved something like x over 3 plus 1 over 5 equals 5 over 6. So there's one way to solve this is just to deal with the fractions as they are. However, a lot of you guys back in Algebra 1 learned that since you could multiply both sides by whatever you want, you could choose a number that would cancel out all of the fractions. In this case, the least common denominator, when we look at 6, 5, and 3, would be 30. So if we choose 30 as the least common denominator, this is not like the addition and subtraction problems. We don't necessarily need to make all the denominators 30. Instead, what I'm going to choose to do is to multiply, sorry about that, both sides by 30. And then what happens is when x over 3 gets multiplied by 30, the 3 cancels out, it leaves a factor of 10, and I get 10x. And then when 1/5 multiplies 30, the 5 cancels out a factor of 5 from 30, leaving 6, and 1 times 6 leaves me with 6. And then when 5 over 6 multiplies 30, 6 goes into 35 times, and 5 times 5 leaves me 25. And I then have a much simpler equation to solve. I can just add and subtract, multiply, or divide and get x alone. So that's going to be our focus. So our focus is going to be to use the least common denominator. So we still need those skills from addition and subtraction. However, we're going to use the least common denominator in a way that's a little bit different. We're going to be multiplying everything by that value. So when I start each problem, like when I look at part A, okay, the first thing I'm going to decide to do is try to find the least common denominator. And to do that, I want to look at each denominator in its factored form. So here's the first denominator. It's 1 factor of y plus 2. So my common denominator is going to have to include that. The second denominator is a factor of 15, so I'm also going to need to include that. My third denominator is 3y plus 6. Before I decide it definitely has to include that, I want to factor the 3y plus 6. So it had a greatest common factor of 3 in those two terms. And so it's really like 3 times y plus 2. And then you'll notice the y plus 2 factor is already present in our common denominator. And actually a factor of 3 is present in there too, because 15 is made up of a factor of 3 and 5. So I don't need to put any new factors in to cover the 3 and the y plus 2. So this is going to be my LCD. Okay. And so remember how we said we're planning on using that LCD because this is an equation. So this is the key. You can't just cancel things out from both sides or do whatever you want unless you actually have two sides of an equation to use those properties of equality. Since this is an equation, I can choose to multiply the entire left side by a factor of 15 and a factor of y plus 2, as long as I also multiply the right side by a factor of 15 and a factor of y plus 2. When I do that on the left side, what I'm really saying is that I'm going to distribute this 15 times y plus 2 to the first fraction and to the second fraction. Okay? And then on the right side, that 15 times y plus 2 is going to multiply the one fraction on the right side. So here's what I'm seeing. I'm seeing that I had a first fraction of 3 over y plus 2, but that's now going to be multiplied by 15 times y plus 2. And then it was added with a second fraction of 7 over 15. That's now going to be multiplied by 15 times y plus 2. On the other side of the equation, I had a 23 over a 3 times y plus 2. That's now being multiplied by 15 times y plus 2. So the reason that this is helpful, and if you have to, these are all over 1, if that helps you picture it a little bit, Now we can look at the multiplication problems we've created, and like we did in the simplifying lesson, we can simplify any common factors from the numerator and the denominator. So here there's a y plus 2, and I'm left with 3 times 15. In the second term, this multiplication problem I've created, 15 is a common factor that can cancel out. And I'm left with 7 times y plus 2. And in this third problem, the y plus 2 cancels out. 3 goes into 15 5 times, and I'm left with 23 times 5. So it might look a little complicated right now. I'm writing out each individual step, and I would recommend that you do the same just to not get lost in the steps. But really here, so I have 45 plus 7y plus 14 equals 23 times 5, which let's see, that would be 15, 115. I'm going to add together the 45 and the 14. That gives me 59. I'm going to subtract 59 from 115. I'm actually subtracting 59 from both sides of the equation when I'm doing that. And so that's going to give me, so here's what I'm doing. I'm subtracting 59. It's giving me 7y equals 56. And when I divide both sides by 7, that gives me y equals 8. Okay. In these problems, I do want to make one big note that you should write on your paper to remind yourself, is that you should check your answers, because your original problems are fractions with x in the denominator. You want to make sure you're not creating something undefined, which would mean if I plug my answer back in, does it make 0 in the denominator? In this case, if I plug 8 back in for y, it doesn't create 0 in any of those denominators, so that's a good answer. Okay. All right, now we're going to look at the next problem. So again, we're going to start with LCD. So when I look at the first fraction, the factor in the denominator is just one factor of x minus 6. The second fraction has a factor of 6. I haven't included that yet. I have an x minus 6. That's different than 6. And then the third fraction has an x minus 2. I don't have that yet either, so I need to include that. So my LCD is going to be a factor of x minus 6, a factor of 6, and a factor of x minus 2. I'm probably going to write it like this. I don't know. Math habits based on how you conventionally see them, write them usually with the number in front. So then what I'm going to choose to do is I'm going to choose to multiply the left side of my equation by this entire thing. So it's going to get multiplied by 6, x minus 6, and x minus 2. And I'm going to multiply the right side of the equation by 6, x minus 6, and x minus 2. Okay, so on the left side, that means this new thing that I'm multiplying by is multiplying the one fraction on the left side. So on the left side, I had x plus 1 over x minus 6. That's now getting multiplied by 6, x minus 6, and x minus 2. On the right side of the equation, this common factor that I've chosen here, common denominator to multiply through, is going to multiply to this fraction of 5x over 6 and the other fraction. It's going to be distributed. So I have 5x over 6 is going to multiply 6x minus 6 and x minus 2. And then I have 1 over x minus 2 that's going to multiply with 6x minus 6 and x minus 2. And now I'm going to go through and I'm going to see how this simplifies. Again, with goals being that I might still have stuff left in this equation, but hopefully no longer fractions. So in this first multiplication problem here, the factors of x minus 6 can cancel, and I'm left with a factor of x plus 1, a factor of 6, and a factor of x minus 2. In the second multiplication problem, the factors of 6 will cancel, and I'm left with 5x times x minus 6 times x minus 2. And then in this third one, this factor of x minus 2 will cancel, and I'll be left with 6 times x minus 6. So the fractions are gone. This is still a little complicated because there is a lot more things multiplying together. So I'm going to multiply together each of the things that are going to make a quadratic first. And if you struggle with multiplying these things together, again, pause the video. Make sure you multiply them correctly and that you're getting the same things that I'm getting here. go. And now I'm still going to distribute this 6 to those terms and this 5x here. So I'm going to have 6x squared minus 6x minus 12 equals 5x cubed minus 40x squared plus 60x plus 6x minus 36. Now I'm going to try to move everything to one side in hopes that I can actually solve this. So notice I'm choosing to add a negative 6x squared, so these will cancel out, a positive 6x and a positive 12, so that I can get all these to cancel out to 0. And so I need to put those same amounts, add or subtract them on this side as well, and I'm going to line them up with like terms that they have. So on this side I have a 5x cubed. These are my only x squared, so negative 46x squared. Here I have a 60x plus a 6x plus another 6x, so that's actually plus 72x, and then minus 24. Now to solve this, we aren't actually having you guys use calculators. If you were going to solve this, you would actually finish this by using a graphing calculator and figuring out what x equals. So for our purposes, I'm just going to leave this right here. We don't have to finish this. It's not an expectation in what we're doing here. You could actually, if you wanted, go on Desmos and you could see, I'll show you. Let me go back and get our equation. So we have 5x cubed. I'm going to type that into Desmos, but I have to try and not forget it. So let's see here. Sorry about the delay. So I would just go graph it for you and we can just find where x is equal to 0 for this equation. If we type it in, so 5x cubed minus 46x squared plus 72x minus 24. So again, I don't expect you to solve this, but just like a little bit extra. So you can see we have an answer there at 0.464, 1.413, and also at 7.323. So we would have 3 answers to this problem. X could equal any of those values there. Okay, but that's a little bit extra from what you guys need to do. All right, we're going to look at our last example now. So I'm going to focus first, on the LCD again. And so I look at our first denominator. It has one factor of 2x plus 1, so I need to include that. The second denominator has a factor of 3, so I'm going to include that. The third denominator is factorable. If I take 4x plus 2, there's a common factor of 2. So it becomes 2 times 2x plus 1. And I already have a factor of 2x plus 1 listed, so the only thing I haven't covered from that factor is 2. Okay, so my LCD is 6 from the 3 times 2, and then also a factor of 2x plus 1. So I'm going to choose to multiply both sides of this equation, so the left side and also the right side, by 6 as well as 2x plus 1. Remember, on the left side, it means it's multiplying this fraction. On the right side, it means it's getting distributed to both of these. So what I'm going to have is I'm going to have that first fraction, well, the only fraction on the left side, getting multiplied by the common factor of 6 times 2x plus 1. On the right side, I have x over 3 getting multiplied by 6 and 2x plus 1. And then also 3 over 2 times 2x plus 1 getting multiplied by 6 and 2x plus 1. And then we're going to take a look at the multiplication problems we've created and how they simplify. So here's the first one, and the factor of 2x plus 1 simplifies, leaving us with x plus 2 times 6. In the second one, 3 goes into 6, leaving a factor of 2. So we have a 2 times an x times a 2x plus 1. And then in the third one, 2 goes into 6, leaving a factor of 3. And 2x plus 1 cancels out, leaving us with 3 times 3, which will be 9. So we're going to have 6x plus 12 equals 4x squared plus 2x plus 9. And this is a quadratic, so just like how we approached the cubic at this point, the last problem we did, I want to move everything over to one side, set it equal to 0, and see if I have any ways to solve it. Here's what I have. So on this last problem that was a cubic, you got here and I kind of told you I wouldn't expect you to solve it any further because we don't have a lot of cubic factoring techniques. We had to use technology. But here for a quadratic, you should be able to finish solving this. So remember, to solve something where the highest power is x squared and is a quadratic, you're looking at methods of factoring or using the quadratic formula. So again, another little factoring review is that the first thing I'm trying to do is figure out when someone multiplied out the two factors, they got something like this. What were these two numbers in the middle? And those two numbers need to add up to -4, so they're worth the same thing as -4x, but they need to come from the multiplication of these other two things and make -12x squared. So two things that would multiply to make -12 but add to make -4 would be 6 and 2, where the 6 is negative. So these two numbers must have been a -6x and a +2x. Then from there, we're looking to factor by grouping, which means to look at smaller groups within the problem. 4x squared and 6x have a common factor of 2x. 2x minus 3 doesn't have any common factor, which means 1 is their greatest common factor. And now when we factor, we're looking what these have in common. I'm taking out what they have in common. When I divide that out of each of the terms, I'm left with each one that it individually multiplied by. So this quadratic does factor. It factors as 2x minus 3 and 2x plus 1. And then remember to solve, we set those equal to 0. So 2x minus 3 set equal to 0 will give you x equals 3 over 2. And 2x plus 1 set equal to 0 will give you x is equal to -1/2. And I have two solutions to this problem at the moment, but I'm actually going to cancel one of these solutions out and call it extraneous because this one, x equals -1/2, actually doesn't work because if I plug it into this fraction or into this one, it causes the denominator to be 0, which would make our function undefined that we're trying to solve. So this is not going to be a solution that we want, but this 3 over 2 can be kept.